Welcome to Inequalities and Systems for Pre-Calculus Math 11. Today we're taking a look at solving quadratic inequalities, which is section 5.1 for us. Basically, we've seen inequalities before, just simple linear inequalities in a previous grade. So we're going to just take a look at what happens when we turn quadratic into an inequality. When the equal sign in a quadratic equation is replaced with an inequality sign, basically we just call that a quadratic inequality. So hopefully you remember that when we have this less than, this little sign without the equal sign, it means less than. And we have less than or equal to when it does contain the equal sign. We also have greater than and greater than or equal to. And again, you're reading kind of from a left to right when you think of these things. So let's take a look. We have a graph here. We have a graph of y equals x squared minus 7x plus 10. On the left here, I graphed it for you. It has some zeros of, it looks like 2 and 5. So when does this function actually equal exactly x squared minus 7x plus 10? When does that actually equal 0? Well, that's a y value. Normally when we graph y equals, here we want y to be 0. So where does that happen? Right on those dots, those black dots. So for here, let me just write down my black dots. Let me switch to a highlighter here now. Where does x squared minus 7x plus 10, where is that bigger than 0? So where is that greater or higher than all the y values of 0? So where do the y values are bigger than 0 is along that curve above. And what happens is, let me mash that down onto the x-axis. We see it's this region outside. So for me, that's in red. Let's try this maybe in green now. Where's the function below? So where does the parabola, and again that x squared minus 7x plus 10 defines our parabola. Where is that below 0? So below 0, below the y or x-axis, is the region in between. So if we can sketch a graph of a quadratic, it's very easy to figure out if we need to shade above or below based on the inequality. So I came up with 4 kind of quick steps here. When we try and solve these things algebraically, I don't want to have to always graph them really precisely, but when we solve them algebraically, we're going to move everything to one side of the inequality sign and factor the quadratic. Now, it's usually easiest to move everything so that the x squared term is positive. I just like factoring when the x squared is positive, but it's completely up to you. Remember, don't forget, when you multiply or divide by a negative sign, you must flip that inequality sign. Step 2 is going to be using the zeros of the equation, roughly sketch the graph. And really, when I say roughly, I mean basically just the zeros and the direction the parabola opened. And we're going to determine the appropriate region based on that. So let's do those 2 steps. I'm going to group 7x squared plus 5x, and I'm going to subtract 2 to the left-hand side. That way we've grouped everything to one side. It's a pretty straightforward quadratic here. This factors. I'm not going to go over that with you. You should know how to factor by now. It factors into 7x and x, and it's minus 2 and plus 1, I'm thinking. And that tells me that the zeros are x equals 2/7 and negative 1 from the factors. Now when I say let's take this and roughly sketch it, we're going to draw our parabola here. I have zeros of negative 1, which is on the left, and 2/7, which is on the right. I'm not being terribly precise. I'm just showing that one's on the left side, one's on the right-hand side of the y-axis. My parabola, because it's a positive parabola, it's a positive leading x squared term, means that it's opening up, and we should have seen that before. So a pretty rough sketch. Doesn't really matter where it troughs there, where the vertex is. That's not a big deal. Now, if we want to determine the region here, I want the parabola, which is 7x squared plus 5x minus 2, to be greater than 0. So where is it greater than 0? Where is it above the 0 line, which is the x-axis? Is that region defined there, region outside of the negative 1 and outside of the 2/7. So step 3 we can see here is consider drawing your answers on a number line. I'm going to do that. Even the check step is probably a good step that you should get into the habit of doing, but let me draw this on a number line. So really simplifying the picture that we just had above, we have -1, 7/2. It's an inequality where there are no equal signs, so I'm going to use open dots. And I'm everything to the left of -1, everything to the right of positive 7/2. Now I have another way to write this if we're looking for this answer. So -1, 7/2, that's the same kind of thing. Let me just make that a little bit more obvious. Same kind of thing to the left and right. One technique I use, which never fails to figure out what the inequality is, you're going to draw an X on the number line in the region that you want. In this case, the region that we're shaded in. So I had a region to the left of -1. I'm going to draw an X. I have a region to the right of 7/2. And once you do that, you just fill in your inequality sign always to the right. It's always a less than or equal to. Basically, the alligator always eats right because we want them to grow up nice and happy and healthy. So picking that information off, we then have that the X is less than -1 or greater than 7/2. So that's a good solution to this. Let's check this solution. We almost have two little cases here I'm going to go through somewhat quickly. We need 7/2 here on the other side. Pick a value in that region. I don't know, let x equal -10. That certainly is smaller than -1. No, usually 10's an easy number to try. Let's plug it into the very first equation here. It was 7x squared plus 5x, and I want to check if it's greater than 2. It's always a good idea to plug it into the very first equation. That way there's less potential for error. -10 squared is positive 100 minus 50. Is that greater than 2? Is 700 minus 50 greater than 2? And is 650 greater than 2? Yeah, you bet that is. So that's probably an appropriate answer. Let's go with trying x equals 10. Same kind of calculation, 10 squared, 5 by 10. So you can follow along here. You can see that this solution of x greater than 7/2 should also work. And we see 700 plus 50 greater than 2. 750, is that greater than 2? You bet. That's also a good solution. Pretty straightforward. You want to group everything together, factor it so that you can sketch it. Why don't you hit pause here, try this second example. It's a little bit more difficult, but not terribly so. Okay, let's take a look here. We have to expand this bracket, so we have -3 times x squared. -3 times -5 is positive 15, and that's less than -4x. What I want to do here again, I like personally moving everything to the side where the x squared term becomes positive. I find that makes it easier to factor a little bit. So I'm going to write everything to the right hand side here. Notice because I'm just adding and subtracting, I don't have to flip the inequality sign. I just moved everything over to the right hand side. Factoring that, we get 3x plus 5 and another x minus 3. And we're going to find the zeros here. Oh, I'm sorry. We're going to find the zeros here, so we're going to go with x equals -5/3 and x equals 3. Those are our two zeros. Quick sketch again. We have -5/3. We have 3. We want a parabola passing through those. And in this case, we again want a parabola, which is this 3x squared minus 4x minus 15. That defines our parabola. We want it to be larger than the 0. It's on the large side of 0. So the large side of 0 again is outside that region there. So number line wise, let me do this in one step. We have -5/3. We have 3. We have open dots again because I have an inequality which is not inclusive. Let me throw some x's in there. And again, we get solutions of less than negative 5/3 and an x value which is greater than 3. Let's go ahead and check this. So we have two cases. We have x less than negative 5/3 and x larger than 3. Let's pick some values. Again, I go with negative 10, 10 a lot. They're nice round numbers, easy to square, that kind of thing. Let's go back to the original equation. 3 times negative 10 all squared minus 5, and I want to find out if that is less than negative 4 times negative 10. I have negative 3. Negative 10 squared is 100. You got to be a little bit careful about the squaring negatives. Is that less than 40? 3 times 95, is that less than 40? 3 by 95 is negative 385. Is that less than 40? You betcha. And I don't know. Let's try 5 this time. Negative 3. 5 squared minus 5, is that less than negative 4 times 5? 5 squared is 25 minus 5, is that less than negative 20? And we end up with negative 60, is that less than negative 20? Again, you betcha. So pretty straightforward, I think. You're going to group everything to one side so you can factor it as a quadratic. Quadratic represents itself with a parabola. We can take a look at if we want to be above the x-axis or below the x-axis. And you know what? Check your answers. Probably a good idea. This ends the notes for solving quadratic inequalities, section 5.1.